Dr. Ranjani Parthasarathi is a professor in Department of Computer Science and Engineering. Her area of specialization is in computer architecture and computer networking. She had guided more than 5 PhD students and currently guiding 5 PhD students. She had published paper in more than 50 national and international journals. She worked in many sponsored projects and she got IBM Faculty Award for 2008.
Welcome to the UGC lecture series in computer science. Today's session will be on networks and introduction. What we will be looking at today is in terms of what is a network, why do we need networks, and how a network works. Network is something that is ubiquitous today. All of us are using networks every day. So we just need to know about what exactly it is, why do we need them, and how these networks actually work. So the objectives for this session would be as follows. We need to understand the basic networked communications and services. We will describe the benefits of networking and we will identify the essential networking functions. So what is a network? It could be as simple as two computers that are just connected with a cable that can transmit data. So I just have two computers and I have a communication media which connects up these two computers. So it could be just as simple as that. Or I could have a much larger setup where I have multiple computers spread out all across the globe and connected using different communication equipment. So I could have something like a number of computers which is part of a company network. You could have laptops, you could have desktop computers. All these are all connected by means of a network, and this network is again connected to other networks using a further set of routers. These routers would be supported by internet service providers called as regional service providers and so on, and they would be providing service to home users who may be connected by means of a dial-up modem through a telephone network. So you could have all these being connected together as a whole network. So when we talk of a network, it could be just a simple two node network or it could be a multiple node network. But what is interesting to see is that whatever be the type of a network, the basic idea is that the computers are connected to share information and resources. The technology that is used could be complex, it could be varied, and there are many choices which are available for physical connections and for the software which make all these things work. So what we need to look at is how these different components actually work together. So why do we need networking? The answer is very simple. It allows groups of users to exchange information and share data. It allows easy and efficient communication among individuals. We look at applications like electronic mail, we look at applications like web access, chatting, social networking. The applications now are endless. Not to leave out the downloading of content, not to leave out the downloading of streaming of data and so on. Basic idea is that devices and resources can be shared, and when they are shared we reduce the cost. So that could be files being shared, it could be a printer being shared, it could be a fax being shared, it could be disk space being shared, applications being shared, or services could be shared. And all the sharing can take place from remote locations. So remote access to machines which are located far and near is one of the major advantages of networking. So if you just look at this picture which just shows sharing of resources, you can see that there are many computers which are connected together and they can share a single printer and a single fax which is connected again to this network. So this is just a simple example of sharing of resources as we use in many of the offices and institutions. So how do we actually establish this networking? So what is it that makes this networking work? So if you look at that, there are basically four things that we need to look at. One is that we need some physical media for communication. So this physical media is where the data actually is going to be transmitted, and the data will not be transmitted as data as such, but it will be transmitted as signals. So the data will be converted to signals and transmitted using some physical media, and then we need some protocols to manage the communication. When data is actually being transmitted from one place to the other, we need to make sure that the data actually goes in the correct format, it reaches in the correct manner and so on. So we need to use something called protocols which manage the communication. Then of course we need the devices which help us to interconnect these different components, and applications which allow the sharing of resources. Application is something that we are already familiar with. So it is more of the other three that we really need to know in terms of how networking is established. Let us look at the physical media. If you look at physical media, it could be as simple as wires and cables, or it could be wireless transmission. If you are looking at wires and cables, we are looking at something very simple networking components like twisted pair cables, coaxial cables, optical fibers. Now twisted pair cable is something that we are all very familiar with. the common telephone cable that we use at home, that is an example of a twisted pair cable. Similarly, we are also familiar with the coaxial cable. The TV cable is an example of a coaxial cable. Optical fiber is also something that we are all familiar with these days. And in terms of wireless communication, which also is something that we are now familiar with the usage of cell phones, it could be radio waves, satellite communication, and your infrared communication. An example of infrared communication is the remote that we use in our TV to control our TVs. So, these are some examples of physical media that are used for establishing the communication between two different computers. So, this is just a picture which shows you the twisted pair cable. What we have in a twisted pair is just a pair of wires which are twisted. So, and these are used to carry the current, carry the signal. So, the picture also shows a Cat5 or an RJ45 cable as it is referred to, which is used for connecting up your computers to the network. Similarly, the other picture shows you an RJ11 which is used in a phone connection. So, just to give you an example of what a twisted pair cable actually looks like. A coaxial cable, you can see that this is what you see in a TV cable. In a coaxial cable, there is a cable at the center, and then there is a shielding, and then there is an outer casing. So, the actual signal is being carried in the central cable, that is in the central conductor which is there. This is an example of an optical fiber. It shows the picture of a hand which is holding a set of optical fibers. You can see the light coming out through these fibers. So, this is again optical fibers used for communication using optical signals, that is light is used to carry the data. Now, that is about the physical media that is required. Now, talking about protocols, what is this? What do we mean by a protocol? Protocols is something which provide a handshake, and they provide the syntax and semantics for a communication. So, let us just take a simple look at a protocol that is used in normal human communication. Typically, how do we start any conversation? We start with a hello, an exchange of hello. So, a person A says hello, B says hello, and then he says, can I talk to you for a minute? And you say sure, and then okay, and then you start your communication. So, this is typically what we have in a human communication, and something like this, very similar to this, is what is used in a computer communication as well. So, to understand this now from a network's perspective, let us look at what the requirements of a network are. If you look at a network, now we said that a network can be a 2-node network or it could be a multiple node network. So, let us just start with the 2-node network, because we can easily understand what the requirements are, and then we will build up onto a multiple node network. So, we start with the 2-node network. What is it that is required to set up a communication for a simple function? Let us say I have a very simple function like transmitting file from one computer to another computer. So, what is it that I need first? First, I need two machines A and B which are connected using some cable. Alright. So, let us look at two machines being connected together using a cable. So, is this kind of just a simple cable connection sufficient to ensure that you are able to transfer data from machine A to machine B? Obviously, this is just not enough. We need something more. Just as we said, we need some handshaking mechanism. So, let us look at the handshaking mechanism that we would require. Typically, what happens in a human communication, one person says a hello and the other person again responds with a hello. So, we have something very similar in this case as well. So, what is it that we have? You have a machine A requesting to send. It sends a signal to machine B asking whether it can send data. So, let us say it sends something called a request to send signal. Okay. So, what we refer to as an RTS, which is referred to as an RTS, as an acronym for request to send. So, now the other side machine B, which is willing for the conversation, it is willing to communicate, sends back a signal saying that yes, I am ready, so you can start sending the data. So, it says okay, I am clearing your transmission, so it says clear to send. Once this happens, now data can be transmitted. But is this much enough in terms of determining whether data can be transmitted? Not really again, because we have just decided that we can start sending data, but we still have not agreed on how this data will be transmitted. Okay. So, if one person speaks English and the other person speaks Tamil, they may not have a proper communication. So, they need to have a language and a syntax using which they understand each other. So, similarly here again the two computers which are communicating need to understand one another. So, we need to have an agreed upon syntax for the data that is being transmitted. The two sides will have to agree on that. So, they can decide on whether they will send blocks of data or they will send one byte at a time. So, they could decide on how the data is going to be sent. So, let us just take a simple example. Let us say I am assuming that I am sending data 1 byte at a time. A 1 byte consists of 8 bits of data. Okay. So, once I have this, let us say I use some kind of a serial communication, I am going to be transmitting 8 bits of data. So, I am transmitting 8 bits of data. I could start with a format which looks like this. I have a start bit, and then I say I have 8 bits of data, and then I have a stop bit. So this could be an agreed upon format between the two computers in order to start communication. So look at what will happen now. So whenever data is being sent, every byte of data will start with a start bit, right? A start bit is, let us say, just a signal which goes up and comes down, which will be followed by the 8 bits of actual data, and that will be followed by a stop bit. Of course, before this we would have had our handshaking, which should have ensured that the request to send was sent and the clear to send was received. Then you will have a series of data bytes which are transmitted like this. So this is something that we could have. So once you have agreed on the communication, now is this enough again for the communication to take place correctly? What we next need is that the receiver must be able to interpret the data correctly. Now what can happen, what can go wrong in this interpretation? You can have some disturbance or interference that comes up in the communication, and that could change the data that was being transmitted. So if a data is changed during transmission, should the receiver machine, which is machine B in this case, should it be aware of it, should it be able to detect it or not? So if an error occurs, we would like that error to be detected. So if you want that error to be detected, then we need something more, right? We need to make sure that there is enough information sent so that the error can be detected. So what you do is you will have to do something to guard against errors. So how do we guard against errors? That becomes the next question. So what do? We can use some simple error detection mechanisms. One of the simple error detection mechanisms that we normally use is what is called as the use of a parity bit. Now, so the same idea of using a parity bit, which is used in many other places in computers, in the computer world, can be used in this case also. So what we do is, this parity bit is nothing but one additional bit which is added, and which consists of some additional information which can be used to detect certain types of errors. We will look at the details of parity in later sessions, but right now let us just assume that we have something called a parity which is added, which will help us to detect an error. So now the format will become one start bit followed by 8 data bits, plus I also add this one parity bit, and then that is followed by the stop bit. So this becomes the data that will be transmitted. So now if you look at the picture, you can see that you will first have an RTS followed by a CTS, then you will have a start bit followed by the 8 bits of data, you will have the parity bit and then the stop bit. So this is the kind of communication that would take place. So with this we can more or less assure that data is being transmitted correctly, and the other side, as soon as it receives the data, if there is an error it detects it, otherwise it gets the data correctly. So we have kind of made sure that some data transmission is able to take place. But again, is this enough? What if the transmitter and receiver are working at different clock speeds? Now this is transmitting data at a particular speed, but the receiver is receiving data at a different speed. So naturally what will happen, it will not be able to receive the data correctly, which means the two sides must be synchronized in terms of receiving the data correctly. So sometimes we talk about what is called as clock synchronization. That is, everything is working based on some clock frequency at the transmitter end, and it happening at some clock frequency at the receiver end. So these two clock frequencies need to be synchronized. So we need to make sure that you have the synchronization taking place correctly. So if you put all these things together, let us just sum up what the requirements are. To sum up the requirements, we need a physical media, which we have seen this, and a protocol which is used for handshaking, format of data, error control, flow control and synchronization. So once we have these, now we are ready to group these functions and make all these things work together. So how do we group these functions? So you have the application which wants to send data, and then you have all these functions that we just talked about. Data link functions, what we refer to as the data link function, which consists of formatting, error checking, flow control, and then you have the actual physical layer which is going to carry the data. So with this we can more or less say that we have put together a system which will actually help us in terms of transmitting data. Again, just a quick question before we look at whether this will work or not. Will this work? More or less yes, provided the applications understand each other. So we are looking at a situation where the applications also need to follow certain protocols. That is, you need to specify some data in terms of what format will be used for transmitting the files, how do you specify the files and so on. So once you have this, the situation we have is something like this. So you have an application which talks to the application on the other side by means of some protocol, data link talks to the data link on the other side by means of some protocol, and then you actually have the physical connection taking place. So this is the basis of any two-node communication to happen. For any two-node communication to happen, this is what you need. Okay. So we will take a small break now and come back and continue on the details later. Welcome after the break. Let's just look at what we were talking about before the break. So, we were talking about how computers actually connect to each other and how they can be made to talk to each other. So, we saw that you need a physical layer which connects up these two computers, and then we talked about certain other functions which need to be done above the physical layer. Once you have the physical layer to transmit the actual data, we have to make sure that the data is transmitted in a correct format and both the sides understand the format in which it is transmitted, and both the sides need to also be able to identify if there is any error that occurs. So, we talked about a physical layer and we talked about another set of functions which we can group together and call it as the data link layer, which will be sitting right above the physical layer. So, now we can look at the data transmission taking place in terms of layers of functions which need to be performed, or rather we are looking at the flow of data through a computer in terms of passing through different layers of communication. So, what is it that we are talking about? We are talking about an application which is going to be actually producing the data that needs to be sent to the other side. So, you have a corresponding application on the other side which is receiving this data, and then from this application the data is sent to this data link layer, which will take care of formatting the data, which will take care of adding whatever parity bits and other things that we talked about, adding some information which makes sure that data can be transmitted correctly to the other side, and then it will be passed on to the physical layer. The physical layer is the one which will convert it into signals and send it on the physical media. On the other side, the physical media will receive it, the physical layer will receive the data, convert it to the data, which it will receive the signals, convert it to data, send it to the data link layer. The data link layer here will check for errors, remove the information that was added by the other side's data link layer and pass on the original data to the application layer. So, what we can see is we have a layered communication model, and this layered communication model is what is normally used on networks, and this forms the network protocol stack, or what we refer to as the network software. So, we have layers of modules which perform different functions, and typically what happens is each layer, each protocol communicates with its peer. So, we have this dotted line which shows that application on one side talking to the application on the other side, data link on one side talking to the data link on the other side, and the physical layer actually establishing the communication. So, now what are the advantages of having such a layered approach? One is we can see that the moment we look at things as layers, we are basically breaking them up into modules. The moment you break up something into modules, a modular approach always has its own advantages. So, if you want to change something, you can change only that part without changing the rest of the system. So, let us say I want to change the application. Earlier we talked about one particular application, let us say file transfer. Now I want to change the application. So, what do I need to do? I do not need to change anything else. I just need to change the application. So, if I say I have a yellow colored application now, which is to be replaced by a green color application, only the application needs to be changed, the data link layer and the physical layer remain the same. No change requires to be done for any of those things. Similarly, let me say I want to change the type of cable that I am using, that is I am changing the physical media. So, what is it that needs to change now? Only the physical layer. So, I have a physical layer. Now, let us say I used a coaxial cable first, I want to change it with a twisted pair cable. So, what is it that changes? Only the physical layer will change and the cable will change. The data link layer and the application layer remain as it is. So, it becomes easy for us to change functionalities without affecting the rest of the system. This is one of the major advantages that we have of the layered communication. Another major application of this layered communication is if I want to support more number of applications. If I want to support more number of applications, what I could do is I could add one more layer between the application layer and the data layer, whose function is to identify the sending application and the receiving application. That is, I could add more functionality in between, or adding layers becomes possible. So, how do I do this? Take this example. So, now I am showing a 4 layered communication. Earlier we talked about a 3 layered model. Now, I am having a 4 layered model. What is it that I have here? I have my physical layer at the bottom, I have the data link layer on top of that, and between the data link and the application that I had earlier, now we have a transport layer, and the application layer itself you can see has got more than one application that we are showing over here. You have an application 1, you have an application 2 and application 3. Correspondingly, on the other side also you have 3 different applications. So, all these applications are going to share the same network to transmit the data. So, to enable this sharing, we have this transport layer. So, what is the job of this transport layer? To identify which application is coming from, add that information and send it to the data link layer. Once the data reaches the other side to the data link layer, from the data link layer it goes to the transport layer, and the transport layer here again will determine from which application it has come and to which application it has to be received. By using that information, it sends it to the correct application that has to receive the data. So, by adding this one more layer in between, we have seen that we have enhanced the function of this 2-node network. So, you can see that even for just a 2-node network, this kind of a layered approach helps. Okay. So, the basic takeaway that you have from this discussion so far is that we use a layered model, and each layer provides different functionality, gives you a modular approach, and we use a protocol at each layer, and then we use a physical media for actual transfer of data. So, this is something that we need to remember in terms of how data is transmitted. So, what we have looked at so far is what is a network, why we need networking, and how data is transmitted in a network. But what we have looked at so far is only a 2-node network. So, now let us look at expanding the network. Now, consider that now I need an n-node network. I am not just connecting up 2 machines, but I am going to connect up n machines together. So, 2 important questions will come up when I look at an n-node machine. First question is, first of all, how do I connect them? And secondly, when there are many nodes connected to a single network, how do I make sure that the different nodes will share this communication medium which is available? So, how do I perform what is referred to as media access control? So, the term we use here is media access control. What do we mean by this term? Media is the physical media that you have, different nodes need to access it, and we need to control who gets access to this media. So, we have a functionality called media access control which needs to be done. So, how to connect the machines and how to do media access control? These are the 2 things that we need to look at when you expand the network to an n-node network. So, how do we actually connect them? You could connect them up using different topologies. So, topologies are something that we are very familiar with. You can connect it in the form of a bus, you can connect it in the form of a ring, you can connect it in the form of a star. So, look at what happens in a ring connection. This is a very easy connection to understand. So, what happens? The different computers are connected to one another in the form of a ring. So, you have links between 2 computers and all the connectors connect to each other in the form of a ring. Another option is a star connection. What do you have in the star connection? You have a central hub to which multiple computers are connected. This is referred to as a star topology. A bus topology is another simple topology where you have a single shared media, different nodes just connect up to this bus, all of them listen to what is being transmitted on the bus and pick up whatever they need. So, these are 3 simple topologies that you can look at. There are of course many other topologies available, but just to get an idea, these 3 topologies are typically sufficient. In fact, one of the most common topologies is the bus topology, which is used in our Ethernet kind of networks. Now, Ethernet network is something that most of us are familiar with because that is what we use in many of the institutions and many of the organizations. So, and that uses the bus type network. So, this is one topology that is a very commonly used topology. Okay, so the second question was, how do you perform media access control? So, what do we need for this? We need to make sure that there is some technique so that transmissions of the nodes do not collide. Now, we know that especially in a bus based network, you can see that all of them are connected to the same shared media. So, if all of them transmit, if more than one node transmits at the same time, their data will collide, their signals will collide. So, that has to be avoided. So, we need to have a mechanism to ensure that the transmissions do not collide. That is the first point. Second thing is, we also need to make sure that no node is starved. What do we mean by this? Now, if one node goes on transmitting data and does not give a chance for the other nodes to transmit, then other nodes will be starved, right? They will not get a chance to transmit. That also has to be avoided. And of course, thirdly, we need to make sure that you are able to use the resources efficiently. A particular media may have a certain bandwidth, a certain capability. So, how is it that that capability is well shared between the different nodes which need to use it? So, that is something that you need to identify. So, typically what will happen in case of media access control mechanisms is that it depends on the topology. So, for different topologies, you have different media access control mechanisms which are used. But in general, just to take away as an abstraction, we can look at the MAC functionality as one more layer which needs to be added just above the data link layer or combined with the data link layer. So, if you look at it from that point of view, so now what we have in our layered model is we had the application, transport, data link and physical. Now, we also have a MAC layer which is added. Normally what we do is the data link layer and the MAC layer are normally combined together. So, we refer to these two together as a single layer, but remember that the MAC functionality is a separate functionality which is added in this. Okay. Once you have done that, now let's just take a few examples of practical access networks which are used. So now let's look at this. Let's take for instance this first figure here, which shows a residential access. That is, I have two machines connected up by means of telephone lines to a network. Now this telephone lines accessing this, how is it that the telephone lines, how do we use the telephone lines to connect up? Basically we use something called a modem, right? We use technologies like dial-up modem, we use ISDN, ADSL, these are all technologies that you would have heard of. So these are technologies which actually allow us to access the network, okay? And how is it that this access is done? There again you will have a particular media access control mechanism which will make sure that ADSL technology will use it in a particular manner. Dial-up modems use it in a particular manner. So you have typical media access control mechanisms which will make sure that the access is shared appropriately. So the next example is that of a local area network, the very familiar Ethernet. So typically what happens in an Ethernet, you have an Ethernet network which is set up and different nodes are connected to this. When you have different nodes connected up to the network like this, then all we need is this. Again you have a media access control mechanism which is specific to the Ethernet, which will ensure that different nodes are able to transmit data to one another and also through the router to the network. So this is an example of a wired access media. Similarly, we also have wireless networks these days. So when you have a wireless network, the situation that we have is something like this. You have different mobile hosts or your laptops and they typically connect to a base station. The communication between these two happens by means of wireless communication, and since the media is a wireless media, you again have a different kind of a media access control mechanism which will take care of ensuring the access efficiently in this kind of a network. So these are just some examples of where media access control is used. Okay. Now let's look at the network becoming bigger. So we looked at an n-node network, now we are looking at a much larger network. What is this much larger network? We are looking at many nodes connected up in an institution's network, a company network, and then you have a regional ISP which is used to connect up all these fellows, and then you have a local service provider which may provide some services to various nodes which are in residences or in some other organizations. So now the devices we are talking about are different servers located at various locations, we are talking about workstations, we are talking about mobile workstations and mobile laptops, and we are talking about routers which are used to connect up these devices. Now routers is one new terminology that we are bringing in. Now these are devices which allow different networks to be interconnected to one another. Okay. So once you have this situation, so look at what happens now. Once you have a bigger network, now we are looking at interconnection of networks taking place through these routers. So what should these routers do? So routers have to find a path to go from one network to another network, from one destination, from the source to the destination. That is, we now need one more layer or one more functionality which is required, which is called as the routing functionality or the network layer functionality. So now if you look at the end-to-end data flow, you can see how the data will flow. Data will flow from a machine through routers, through various routers to the final destination, let's say which is a server in this case. And you can have multiple such communications taking place simultaneously in the entire network. So this is the kind of end-to-end data flow that you will have. So now we talked about adding the network layer in between. So now with the network layer added, we have this normal 5-layered model that is used in our internet work these days. So what does this picture consist of? You can see that you have an application layer, you have a transport layer, then we have this network layer added in between, then you have the link plus the MAC layers. I told you that these two are normally grouped together, and then you have the physical layer. So this 5-layer model is what is required in order for communication to take place effectively in an inter-network scenario. So this is what we need for a network to work. So of course there are a lot more details that we need to understand in terms of how this connection takes place, what is it that happens in each of these layers, and what happens when you have different protocols interacting with one another and so on. Those things we will defer for later sessions. Let us quickly summarize what we have been looking at in today's session. Very briefly, we looked at what is a network and why we need networks, and we also looked more into how a network is organized, how is data transferred through a network, and the use of various protocols and layers in a network. So what is a protocol, why we need protocols, and why we need this layered communication. This is what we have looked at in this introduction to networks. Just to test our understanding of whatever we have learned today, so let's try and see if we can answer a few questions. Question number 1, why do we use a network? I think the answer is very simple. You should be able to figure it out yourself. Question number 2, why are layers needed? Question number 3, what does a MAC layer do? Question number 4, what are the 5 layers for a complete network with multiple nodes? Try and see if you can answer these questions. We will continue in the next session. Thank you.